Have you ever seen a motor grader working in your city, leaving the ground perfectly leveled with each pass? What's most surprising is that its tires can tilt sideways. What is this for? In this video, you will discover that, along with the impressive maneuvers this machine can perform. Let's start with the traction system, which transfers the power from the engine to the wheels. The diesel engine converts fuel energy into mechanical energy, which then passes to the transmission. This transmission, known as contragez, regulates speed and torque and allows the machine to operate with 8 forward gears and 6 reverse gears. Its main advantage is that it prioritizes speed over torque, enabling the machine to move quickly, which is ideal for leveling, cutting, and drilling tasks. Then the movement passes to the differential axle, which distributes power to the wheels, allowing them to rotate at different speeds when the motor grader turns or works on slopes. The final drive system is planetary, where the movement enters through the central gear, solar, and is multiplied through smaller gears. The power then reaches the tandem assembly, which uses chains submerged in oil to transfer movement, allowing it to work with constant loads and movements. The steering system is not mechanical, as in traditional vehicles. It uses hydraulic cylinders and a coupling bar that keeps the steering geometry stable. The most interesting part is the wheel tilt system, which helps reduce lateral resistance when cutting and improves traction, especially on slopes. This adjustment is made by a hydraulic cylinder. Finally, the central articulation connects the front and rear chassis, allowing them to angle up to 25 degrees. This facilitates maneuvering in tight spaces and enhances efficiency, in addition to allowing the front section to move independently, which is useful for tasks such as making ditches. On the front axle oscillation mechanism allows the wheels to adapt to the terrain irregularities, improving the stability of the motor grader. It works like a seesaw, allowing one wheel to rise while the other drops. This system is a perfect complement to the wheel tilt, helping maintain maximum contact of the front wheels with the ground and improving stability during work, especially on uneven terrain or slopes. The drawbar, located at the lower front part of the motor grader, connects the front frame with the circle and the blade, transmitting the pushing force to the blade. A key component of this bar is the drawbar ball, a spherical coupling that allows the system to move freely when activated. This mechanism is crucial as it bears the tractive efforts generated by the blade's resistance when in contact with the ground. The ball can be easily replaced thanks to the bolts holding it, and its spherical shape allows a wide range of movement, which is essential for working in different positions and conditions, making the motor grader more flexible in its operation. The circle is another important component of the motor grader. This large-toothed ring, located between the drawbar and the blade, allows the blade to rotate and position itself with high precision relative to the machine's axis. At the bottom of the circle is a hydraulic motor that enables rotation. This motor uses a combination of a worm screw and a helical wheel, providing high torque when the blade faces large loads. This system not only allows for precise adjustments of the blade but also prevents reverse rotation, which is crucial for maintaining stability and preventing damage to the system during work. This technology is vital for fine adjustments and system protection. If the motor grader's blade hits a hard object like a rock, the logical outcome would be damage to the mechanism. However, there's an ingenious solution to prevent this: the slip clutch system. This system transmits the torque from the crown to the lower gear, but only up to a specific torque limit, which is calibrated with 3 bolts located at the top. When the blade hits a hard object, the discs within the system slip against each other, absorbing the impact and protecting the mechanism. In larger motor graders like the Caterpillar 24, a dual hydraulic motor system is used in the circle, which further enhances efficiency and the machine's ability to work in extreme conditions. The blade is one of the most visible and versatile components of the motor grader. It is responsible for cutting, moving, shaping, and leveling the terrain. To control it, 2 hydraulic actuators are used. The first is a cylinder that allows the blade to tilt forward or backward. When tilted backward, the cutting edge becomes more aggressive, ideal for cutting through hard or compacted material, When tilted forward, the cut becomes softer, which is more suitable for fine finishing work, where the goal is to level without removing too much material. The second hydraulic actuator allows the blade to move laterally, which is especially useful when working near edges, slopes, or ditches, where it is not always possible to position the motor grader directly on the work axis. The motor grader's lifting system includes hydraulic cylinders located on each side of the machine, are connected between the rear end of the drawbar and the main frame. These actuators allow the blade and circle to be raised or lowered, adjusting the height of the blade relative to the terrain. The power of these cylinders is impressive, as they can lift the entire front structure of the motor grader. Additionally, there is a front counterweight that helps balance the forces on the front frame. This improves the machine's longitudinal stability, increases the adhesion of the front wheels, and reduces excessive strain on the hydraulic cylinders and structure. Without this counterweight, the motor grader would be more unstable, especially during deep cuts or when the blade is extended out to one side. The link bar is a system designed to increase the reach and positioning of the motor grader's blade. This mechanism allows the grader to perform tasks such as moving earth in distant rows, cleaning deep ditches, or cutting on steeper slopes. In the center of the machine, there is a small hydraulic cylinder called the link bar, which modifies the working geometry of the drawbar, thus affecting the blade's behavior. To adjust the reach, a central change is unlocked, allowing the bar to be moved freely and placed in the desired position. This system is useful for complex tasks like cutting slopes, where the blade is extended to one side. Medium-sized motor graders have this system, but larger ones like the Caterpillar 24 do not, as they are designed to move large volumes of material in mining environments where a precise finish is not required. Modern motor graders have undergone a significant technological advancement, especially in control systems. Now, instead of using mechanical levers and traditional steering wheels, the machines are equipped with joysticks, allowing for much more intuitive control. These joysticks not only reduce the operator's physical effort, but also provide a faster and more precise response, especially when constant adjustments are needed while the machine is in motion. Additionally, modern grader cabs are designed to offer optimal visibility, with large windows and structures that minimize blind spots, making it easier for the operator to clearly see the blade, wheels, and the surrounding work area. The reaper, or ripper, located at the back of the motor grader, has a different function than the blade. While the blade is responsible for cutting and finishing, the reaper is designed to break hard materials that cannot be worked directly with the blade. This component consists of high-strength steel teeth mounted on a robust frame and is powered by a hydraulic cylinder. Its design allows it to penetrate and fracture the ground, preparing it for the blade to work more efficiently afterward. In low compaction or loose soil conditions, motor graders face the challenge of maintaining constant traction, as the wheels can slip and sink, especially when the blade is working with a load. To solve this, anti-slip chains are used and installed on the tires. These chains create multiple contact points, improving the wheel's grip on the ground and transmitting better traction to the soil. Despite safety measures, accidents can occur, such as when the motor grader tips over or gets stuck in loose terrain. In these cases, other equipment like a front loader or backhoe can be used to lift the machine. However, some experienced operators can get out of these situations using the lifting cylinders and the blade as support. The Champion's 100 tons is the largest motor grader in the world, with a blade longer than 7 meters. Although its size and complexity made it costly and uncommon, it marked a milestone in the evolution of motor graders. Today, the industry prefers large but balanced motor graders, especially for mining tasks, where they are used to maintain haul roads and ensure smooth surfaces for mining trucks. Finally, the tandem oscillation system, present in the rear wheels, is designed to reduce vertical movements of the blade when working on uneven terrain. This system improves the machine's adaptation to the ground, optimizing the performance and stability of the motor grader. Would you dare to operate a motor grader, or do you know someone who works with them? Let me know your answer in the comments. Give a like and subscribe if you enjoy this content. See you next time.